Today's video is brought to you by Surfshark. Safety and security online are critically important, and you can protect yourself online with Surfshark. More on them in a bit. Over 2.6 billion kilometers from Earth sits one of the least understood objects in our solar system. The seventh planet, the first discovered in the modern era, has been studied up close just once, when Voyager 2 zipped past in 1986 on its journey to the stars. But that close encounter revealed enough to keep us puzzling for a lifetime. There was the planet's retrograde rotation, the only known example aside from Venus, its axial tilt so extreme that it seems to be tipped over on its side, the geography of its largest moons now thought to house ice volcanoes and subsurface oceans. Yet despite all its tantalizing mysteries, most people just know the seventh planet only as the butt of endless jokes, for obvious pun-worthy reasons. Named Uranus, Planet 7 is science's gift to sniggering schoolkids. A world of methane that, thanks to an abundance of hydrogen sulfide, literally smells like farts. But while the jokes are amusing, there's more to the seventh planet than just recycled Beavis and Butthead gags. With a flagship NASA mission likely in the works, today seems like a good time for us to dig into the story of this distant world and try and prove why Uranus really is the most enticing destination of all. Alright, so we might as well get this out of the way. This video is all about a planet with a name that sounds like your anus. That's probably the one fact most people reliably know about the distant ice giant orbiting 2.9 billion kilometers from the sun, a distance so far it takes light 2 hours and 40 minutes to get there. And that's fine. I'm not here to tell you that the name Uranus isn't funny, or that you should feel bad for giggling every time I say a phrase like NASA wants to probe Uranus.
I'm sorry.
It's human nature to just find this stuff amusing, but what I am hoping is that after this video, butt jokes won't be the first thing that springs to your mind when you hear Uranus, or at least not the only thing. Because, as we're about to see, the seventh planet's comedy name tends to obscure how utterly weird a place it is. Located way out beyond Saturn's orbit, Uranus exists, like its sibling Neptune, in a strange in-between state, neither a massive gas giant like Jupiter, nor a small and rocky world like the terrestrial planets. While our planet could fit inside Jupiter 1,300 times over, it would take a mere 63 Earth-sized planets to match Uranus's volume. It's not exactly a small space, but it's hardly on the scale of our fifth planet. For this reason, Uranus and Neptune have their own classification, ice giants, and it's here that things start to get rather odd. When you read up on them, you discover there's nothing icy about these giants at all. Rather than vast balls of water ice, the gas giants are mostly a dense hot soup of fluids swirling around a rocky core. Unlike the gas giants Jupiter and Saturn, which are mostly made up of hydrogen and helium, Uranus is mostly methane, water, and ammonia, elements which were probably frozen solid at some point during planetary formation, hence the name ice giant. Yet it's not just the seventh planet's classification that's a bit linguistically odd. Unlike all our other planets, Uranus is named for Greek rather than Roman mythology, after the sky god who fathered the Titans. Its 27 moons too have a unique naming system. Instead of mythology, they all take names from the works of Alexander Pope and William Shakespeare. That means you get moons like Oberon and Titania, both taken from A Midsummer Night's Dream. Although quite how scientists have missed the wide-open goal of naming a moon after Shakespeare's character Bottom is totally beyond us. But this stuff is merely cosmetic, a quirk of classification rather than any inbuilt weirdness. Luckily, the planet's oddness goes deeper. The proud owner of 13 thin rings, Uranus has some of Saturn's raw beauty, if Saturn were a blind drunk hobo rolling around in an alleyway. Uranus is lying on its side, its tilt so extreme that it doesn't so much spin through space as rather rolls through it. Our working assumption is that this is due to a long ago collision with an object the size of Earth, one so violent it held the planet off balance. Yet even if we know the reason, it doesn't mean the effects aren't truly bizarre. Because it lies on its side, Uranus has the most extreme seasons of any planet. For half of its trek around the sun, a trek equivalent to 84 Earth years, one or other hemisphere is plunged into complete darkness, a suffocating winter that lasts 20 21 long years. If that wasn't enough, it also spins backwards. While Earth and nearly all planets in the solar system rotate counterclockwise, Venus and Uranus are the annoying hipsters of the group, going against the flow by rotating clockwise. In both cases, we don't really know why. It's possibly because of wizards. But then, that's just Uranus. Pretty much everything about it can be summed up with, yeah, it's weird. And no one really knows why. There's the screwy magnetic field, a trait shared with Neptune, which doesn't pass through the center, making it stronger in the northern hemisphere than in the south. There's also the lack of any internal heat source. Normally, big planets have big internal heating systems, which give out more thermal energy than they receive from the sun. Jupiter, Saturn, and Neptune all have these internal heat sources. But apparently, Uranus just doesn't, or not much of one. Which may explain why it's the coldest planet, with a minimum temperature of minus 224.2 degrees Celsius, making it colder than even the far more distant Neptune. Yet even now, we've only just begun to scratch the surface of Planet 7's weirdness. To get to the really freaky stuff, we're going to have to go in for a closer look. Before we begin our voyage to Uranus, we should note that it's currently impossible to send a crewed mission to the ice giants. I mean, humans haven't even successfully landed on Mars. But let's forget all of that for a second. Let's pretend Elon Musk has built us a special sci-fi ship that'll get us there. Let's pretend that we're blasting off in it right now. We're Stardust Crusaders riding a golden wind of rocket fuel past the stone ocean of our moon and on to infinity. In this hypothetical scenario, what will we see? On approach, Uranus would appear as it does in the famous Voyager 2 photos, a blue-green dot, a colour due to its abundant methane. When sunlight enters the planet's atmosphere, it's reflected back by the clouds below, but since methane absorbs the red, it leads to the eerie cyan from the Voyager pictures. Speaking of those pictures, one of the most disappointing revelations about Planet 7 was how boring it looked, a featureless orb with only a dark spot and a handful of visible cloud shapes, wholly unlike the dynamic swirls that are visible on Neptune. Yet photos can be misleading. Using the Hubble telescope, we've since observed Uranus at different times of its year and witnessed utterly bizarre cloud formations twisting around as it nears equinox. So, depending on when in the Uranian year the Geographics probe arrived, our first glimpse might be of a dynamic, shifting world. The next stage of our fantastic voyage would be to drop down into the planet's atmosphere. As the craft ascends, we'd pass through an atmosphere of methane, yes, but also hydrogen, helium, ammonium, and some trace amounts of water. It's at this point that stepping outside in your mankini would become even less advisable than usual. Up here in the Uranian atmosphere, temperatures drop to the lowest of the lows that would make even a Siberian bear think about putting on an extra layer. The wind speed, too, reaches ungodly levels. Uranian winds slice through the clouds at up to 900 kilometers per hour, faster than even the wind swirling around Jupiter's great red spot. Not that you'd have much time to appreciate them, because the next part of our journey involves escaping this extreme atmosphere and plunging down towards the even more extreme core. Entering the inner structure, things would immediately start to get weird. 80% of Uranus's mass is thought to be made up of incredibly hot, incredibly dense fluids swirling around a hidden rocky core. The closer you get to the core, the hotter it becomes, and the higher the pressures, until you're looking at insane readings like 5,000 degrees Celsius and pressures 6 million times greater than atmosphere on Earth. In fact, it's thought the forces acting on this soup of methane, ammonia, and water become so extreme right near the core that the former fluids are compressed into freaky quantum states. As a result, it may not actually be clear where the core begins and ends. Like Jupiter, Uranus may have a fuzzy core with indistinct boundaries. Before we reach this boundary, though, we'll have a chance to glimpse one of the solar system's most spectacular effects, one only found on Uranus and Neptune: diamond rain. With the interior of Uranus suffering such extreme pressures, odd things start to happen. Methane molecules break apart, releasing their carbon. These scattered carbon atoms then start to collect together, first forming chains and then being squashed into crystalline shapes. In other words, diamonds. But these diamonds aren't unbreakable. Once formed, they fall like rain toward the really hot parts around the core. When they get close enough, they evaporate. The vapor then drifts back upwards towards the cooler regions, where it reforms back into diamonds, and the whole thing happens all over again. A freaky version of our water cycle featuring precious stones. Sadly, though, all this freakishness has one major downside. At no point in our journey are we likely to encounter any forms of life. As regular viewers of this channel's subgenre of basic graphics already know, one of our favourite things is discussing odd places in our solar system where microbial life is theorised to exist, from the briny pools beneath Ceres' crust to the freezing depths of Titan's methane lakes. Yet even the most optimistic astrobiologists rate our chances of finding Uranian life lower even than Meatloaf doing that for love. The temperatures, the pressures, the chemicals, all of it is just so inimical to every kind of organism we can imagine that even simply life evolving is likely impossible. While it's thought some Uranian moons have subsurface oceans which could potentially house microorganisms, the seventh planet is itself likely dead. Okay, so that's Uranus in all its gassy glory. That means it's time to turn our attention to the second part of Planet 7's story, its history. Alright, we'll get back into today's video in just a minute, but first, here's a word from today's excellent sponsor, Surfshark. Surfshark VPN wants you to get the most out of your internet experience, which is why it provides two fundamental 21st century services: superior security and additional options online. First, the security. There's all sorts of weirdos out there on the internet, but with Surfshark, public Wi-Fi doesn't have to be scary. Surfshark offers military-grade encryption and even multi-hop security options so that your IP can be secured from any connection in the world, whether you're traveling the world or just traveling to Starbucks. Worried about geofences or government censorship? Don't be. Surfshark has more than 3,200 servers in 65 countries, so you can live online wherever you like. And that brings us to service number 2, more options online. Lots of people use VPNs to gain access to different streaming options. So do yourself a favor, check out Netflix's from around the world. You get a totally different library. But Surfshark is more than just a source of new movies and television. There's also cookie pop-up blocker, an IP rotator, GPS spoofing, an automatic kill switch, and more. And as is the case with any good VPN, Surfshark keeps absolutely no logs. They also offer a 30-day money-back guarantee if you don't like it. Right now, you guys can get 83% off and 3 months for free at surfshark.deals/geographics, or just follow the link in the description box below. And now back to today's video. When talking about the first 6 planets in our solar system, Mercury, Venus, Earth, Mars, Jupiter, and Saturn, it's debatable whether any of them can claim to have been discovered at all. Visible in the night sky, even with the naked eye, the classical planets were probably known to prehistoric humans long before the ancients got around to recording their movements. Certainly by the time you get to the Babylonians, they were widely known. The same, however, can't be said for Uranus. After endless, impossible eons of human history had passed, the 7th planet suddenly appeared, emerging out of the darkness to upend everything astronomers thought that they knew. The man who upended our millennia-old conception of the solar system: William Herschel. Born Friedrich Wilhelm Herschel in 1738, the future astronomer spent his early years in the electorate of Hanover, today part of what is now northwest Germany, but then it was a powerful statelet within the Holy Roman Empire. Yet while it was geographically small, Hanover had a connection with one of Europe's rising powers. Since 1714, with the ascension of George I, Hanover had been in personal union with the Kingdom of Great Britain. The upshot of this was that in 1757, Herschel would be able to up sticks and move to England, eventually settling in the city of Bath. By now, the young man was both a veteran who'd seen action in the 7 Years' War and an exactingly trained musician. It was this latter training that provided him his income, allowing him to live in a fashionable townhouse. But while he enjoyed music, it wasn't Herschel's passion. No, his heart and soul belonged not to the earthly arts, but to the stars. The mid-18th century, was a time when knowledge of telescopes and astronomy was spreading, becoming something that the upper middle class could indulge in. And indulging in astronomy was what Herschel was all about. Fascinated by the heavens, he and his sister Caroline eventually began making their own reflecting telescopes that were far more powerful than anything they could buy. It was painstaking work that involved hours spent hunched over, grinding and polishing delicate metal plates into perfect light-focusing curves. By the late 1770s, though, they'd gotten so good that their homemade telescope is thought to have been the most powerful on Earth. It was this that would soon lead Herschel to his record-breaking discovery. Now, we should be clear that Herschel wasn't actually the first person to spot the undiscovered planet. The former British astronomer John Flamsteed had noted Uranus at the end of the 17th century. Further, the French stargazer Pierre-Charles Lemonnier had logged it while Herschel was busy fighting in the 7 Years' War. Heck, there are even some who think Hipparchus may have found Uranus way back in ancient Greece. With a magnitude of plus 5.7, it's just in the realms of possibility that a dude with supernaturally good eyesight on an extremely dark night might just have been able to make it out. But while Herschel wasn't the first man to gaze longingly at Uranus, he was the first to prove one very important thing: that this distant pinprick of light wasn't just another star. On March 13, 1781, the astronomer was in his back garden in Bath, deep into a series of systematic observations of the night sky. At some point, he noticed a distant pinprick of light, recording that it was probably just a star, just as Flamsteed and Lemonnier had done decades ago. The key difference was that Herschel then went back to check. On March 17th, he focused again on that point of light and discovered that it had moved. Not much, just a fraction compared to the frozen star field in the background, but Herschel knew a star wouldn't shift position in this way. He'd discovered something else entirely. Not that anyone initially believed that it could be a planet. Even Herschel assumed that it must be a new comet, and while that was cool, it wasn't exactly mind-blowing. It was only when other astronomers went to confirm the discovery that it became clear that the comet had a nearly circular orbit, one which the German astronomer Johann Elert Bode calculated lasted a staggering 84 years. And there was only one known class of objects that moved in such a way: planets. The announcement of a brand new planet lurking in our solar system was the Georgian equivalent of breaking the internet. William Herschel became a global celebrity overnight. So pleased was the British establishment that he was awarded a royal pension so he could ditch music and devote himself full-time to astronomy. Weirdly though, there was one honour that eluded him. As the seventh planet's discoverer, Herschel seemed the perfect candidate to name it, which he did. He called it Georgium Sidus, after the reigning king, George III. Only the rest of the world went, naming a planet after a British king. We're going to come up with something much, much less silly, aren't we? And so it was that the German-speaking Bode got to name Herschel's planet, picking out a solid mythological name, likely without ever realizing how Uranus sounds to English-speaking ears. For their part, the British kept stubbornly calling it Georgium Sidus until long after Herschel's death, only at last updating their guidelines in 1850. By then, of course, it was too late to choose a less embarrassing name. After its 1781 discovery, it arguably took over 2 centuries before humanity's next great interaction with the seventh planet. Now, sure, we did have some luck finding its largest moons. Herschel himself spotted Oberon and Titania just 6 years after sighting the planet itself. This time, it was his son John who came up with the names, thereby saving everyone the embarrassment of Bode deciding to call them Backside and Fanny, or something equally preposterous. Arguably, though, the most significant date for Planet 7 came on September 23rd, 1846, just a handful of years before the moons Ariel and Umbriel were found, when the discovery of Neptune ended Uranus's reign as the only new planet. But really, it's not until the 20th century that our understanding of the distant ice giant took another leap forward. The first discovery came on March 10th, 1977, when scientists in Australia observed Uranus passing in front of a distant star and were shocked to discover that it had rings. But this was just the warm-up, the aspiring local group getting everyone excited for the main act. And the name of that act? Voyager 2. Launched from Cape Canaveral on August 20th, 1977, Voyager 2 to this day remains the only man-made object to have ever visited the ice giants. It's thanks to this one wonderfully retro-looking science mission that we have crisp photos of the outermost planets, that we know almost everything we know about these two worlds. Remarkably, we discovered all of this in just a handful of hours. Voyager 2 zipped past Uranus on January 24th, 1986, beginning a flyby that took it within 81,500 kilometers of the Uranian clouds. It was during this short visit that we found 10 of the seventh planet's moons, that we first measured its freakishly strong magnetic fields, that we got our only ever close-up looks at Miranda, Ariel, Umbriel, Titania, and Oberon. In fact, Voyager 2 took so many readings around the planet that we're still making new discoveries in the data. As recently as 2020, scientists announced that they'd just found evidence that a huge plasma bubble erupted out of the planet during Voyager's visit, one over 20,000 times bigger than Earth. For all of its scientific importance, though, the probe's visit was over nearly as soon as it began. After 45 hours of flyby, Voyager 2's brush with Uranus had finished. Even now, over 36 years later, it remains the only time we've ever come close to the seventh planet. And that's a shame. Because if we can discover so much cool stuff in just 45 hours, imagine what we could find in a mission that lasted years. Importantly, this could include how the ice giants came to form. Right now, the 2 outermost planets in our solar system are the annoying mysteries of planet formation. Our theories for how small terrestrial planets like Mars and Earth form seem pretty solid, as do our theories for how massive monsters like Jupiter and Saturn come about. But we can't quite figure out how something could reach the mass of Uranus and not then just keep on growing until it became a gas giant. This is increasingly becoming a serious question. The more exoplanets we discover outside our solar system, the more it's starting to look like ice giants might be the most common class of planet in our galaxy. Solve the mystery of our seventh planet, and we might just come to understand a heck of a lot more about the entire Milky Way. The Uranian moons, too, might be full of surprises. During the 8 years the Galileo craft spent exploring Jupiter's system, it discovered a deep, potentially life-supporting ocean below the surface of Europa. During a separate mission around Saturn, Cassini found the moon Enceladus emits geysers of water. With hints in Voyager's photos of cryovolcanism or ice volcanoes on some of Uranus's moons, who knows what a future mission to the system could discover? Well, we've got some good news. While not yet confirmed at the time of writing, a NASA mission to the seventh planet is now very much on the cards. Which begs the question, what might a future Uranian probe look like? The Planetary Science Decadal Survey is a remarkable little thing. A survey of brainy science types. It comes out every 10 years and helps influence what projects NASA will prioritize over the following decade. The last decadal, published in 2011, recommended as highest priority a Mars sample return mission and a probe to explore the Jovian moon Europa. These went on to become the Perseverance rover that's been exploring Mars since 2021 and the Europa Clipper, due to launch in 2024. In other words, even though the results don't officially determine policy, NASA tends to listen to the survey. And that's great news for fans of the seventh planet, because when the most recent decadal dropped in April 2022, its highest priority wasn't yet another Mars mission, or a return to the moon, or some experimental journey out to the Kuiper Belt. No, it turns out that what planetary scientists want to do most of all is probe Uranus. Specifically, the report recommends sending a double craft operating as a flagship mission, similar to the increasingly successful Cassini-Huygens mission to Saturn 20 years ago. That would mean a main orbiter craft that could not just study the atmosphere, rings, and magnetosphere around Uranus, but also divert itself to examine the moons in closer detail, mapping their frozen mountains and checking for signs of a subsurface ocean deep below the crust. At the same time, it would also mean a separate probe designed to do nothing more than dive headlong into the seventh planet, taking myriad readings as it embarks on a suicide mission through the atmosphere and toward the core. For planetary scientists, such a mission would be like Christmas, Thanksgiving, Festivus, and Kwanzaa coming all at once, a blowout celebration of discovery. And make no mistake, we would discover a ton of new stuff. During their lifetimes, both the Galileo and Cassini crafts completely upended our understanding of Jupiter and Saturn, in some cases discovering stuff we didn't even know we should be looking for. Now, scientists are hoping to do the same for one of the ice giants. There's just one catch. Such a flagship mission is not going to come cheap. As of spring 2022, the estimated cost of a combined orbiter and probe to Uranus is $4.2 billion. Given the relatively narrow NASA budget, that's a big chunk to ask for. So big that the decadal survey envisages two outcomes: an optimistic one where far-sighted politicians give the agency a budget increase, and a modest one where funding barely keeps track with inflation. Under the optimistic scenario, work could begin in time for an early 2030s launch, an important date as it would allow the probe to get a gravity assist from Jupiter, shaving nearly 3 years off its journey. Under the modest scenario, though, we'd be looking at a late 2030s launch, meaning the probe might not even reach the Uranian system until 2049. And that's if NASA funds it at all. While the decadal survey normally shapes funding priorities, there's always a chance that the money winds up being directed elsewhere, to completing the Mars sample return mission, say, or on some new priority we're not even currently aware of. Still, touch wood, a flagship Uranus mission right now looks more likely than it ever has before. While that clearly means a decade of cheap, irresistible jokes, it also means a decade of serious scientific advances. And as we've hopefully shown in this video, the ice giants remain our solar system's least appreciated mysteries. Two vast, complex planets, about which we know frustratingly little. The idea that we might, in the very near future, finally uncover their origin stories is awe-inspiring, a real step towards understanding not just our seventh planet, but the mysteries of our wider galaxy. If nothing else, it makes this sign-off possible. After decades of ignoring it due to its chucklesome name, perhaps this will be the era in which we, as a species, at last learn to appreciate Uranus in all its gassy glory.